Hi guys, welcome back to another lesson on linear functions with Mrs. Manley. Today we are going to start off by talking about comparing linear functions, but before we can do that we need to do a quick review of the different types of linear functions that we might see. Alright, so just a quick review. One type of linear function that we might see would be a table. So I'm going to quickly draw us a table here. Let's do -2, 0, 2, 4, 1, 6, 11, 16. Let's actually make those negatives. Excuse me. Alright, so when we're looking at a table, we need to be able to compare things like the rate of change in the y-intercept. So in order to write the equation, you need to find all those things. So I need an m, which is my y-intercept, or I'm sorry, my rate of change or slope, a b, which is my initial value or y-intercept, and then I can write my equation. So to find slope, there's a couple different ways you can do it. I prefer just looking to see how it's changing, and you have to write it as the change in y over the change in x. Okay, which is where our slope equation, y2 minus y1, the change in y, over x2 minus x1, the change in x, comes from. So you can use y2 minus y1 over x2 minus x1 by, labeling some points, x1, x2, y1, y2. So that's an option. But if you can see it's changing constantly by the exact same amount all the way down, then that's all we need to look for. The only time we run into a problem doing it that way is if points are left out on a table. So if I look at this one, from -1 to -6, I'm going down 5. -6 to -11 is down 5. -11, -16, down 5. I'm getting more and more negative. So my change in y then is -5. How are my x's changing? -2 to 0 is adding 2. 0 to 2 is adding 2. 2 to 4 is adding 2. Right? So then my change in y is -5 over my change in x is 2. A negative over a positive makes a negative, and I leave it 5 over 2. Yes, I know you could change that to -2.5, but we need to remember that finding the rate of change on a table is the same as finding the slope of a graph. And the slope of a graph, we need a rise over a run. We don't have that when we convert it to a decimal. Then I want to find my y-intercept. So I'm going to go to where x is equal to 0, which is here. And it's going to be -6. Remember, the reason that it's always where x equals 0 is because when you're looking at a graph, your y-intercept has to be on your y-axis. So no matter where it is, it's going to be 0, comma something. 0, comma something. Okay, so 0, comma, in this case, -6. Then I plug it in. Y equals -5 over 2x. Yes, you must have the x. And then -6. Okay, so that's one type of function that I could deal with. All right, another type of function I could deal with would just be an equation. So y equals 3x plus 4, where I need to know that the 3 is my slope, my m, and the 4 is my y-intercept, also known as initial value, which is my b. Okay. Now, I would also need to know that if this was written in standard form, 4x plus 2y equals 6, that I could change it to slope-intercept form by moving that x to the other side of the equal sign, getting 2y equals, slope comes down first, then y-intercept, and then dividing by 2 all the way across. Y equals -4 divided by +2 is -2x. 6 divided by 2 is +3. Okay, and then again I would know slope, y-intercept. And then the last we would come across would be a graph, which I'm not going to do a great job here, but I'll do my best. Let's change colors. So now let's say 4, 1, 2, 3, 4, 2, 3, 4. 1, 2, 3, 4. Okay, so alright, so this is not going to be perfect because I'm hand drawing it. But if I was writing the equation of this, then I would find slope and y-intercept and write my equation. Okay, so in this case, where I just happen to draw my lines, that y-intercept would probably be like 0.25. Normally it's going to be a normal number, but we'll just go with what I hand drew. And then I would find my rise over run. So I could draw in a slope triangle here. And I could say, and ignore this point right here that I drew. I was just trying to figure out what the decimal would be. So this is -1, this is -2, 0. So I went rise 1, rise 2, rise 3. So I'm rising 3, okay, because I got a point here at -2, here at -1, here at 0, and then at 1. So I started here. So I went 1, 2, 3. And then I'm going to go over 1, 2. And I'm going to the right, so it's positive. So I would have y equals 3. Sorry guys, my pen keeps going out on me. 3 over 2x plus 0.25. Okay, so those are different types that we could run into. We could also have a sequence that we would need to convert to slope-intercept form. So I might have 3, 7, 11, 15. And then my formula is a sub n equals a sub 1 plus d times n minus 1. Sorry, everything's sideways right now. So I would say a sub n equals, my first term is 3. My difference is I'm adding 4, so plus 4 times n minus 1. Then I would distribute, so 3 comes down, 4 times n is 4n, 4 times -1 is -4. Bring down my 4n, and then combine 3 minus 4 is -1. So a sub n equals 4n minus 1 is the same as saying y equals 4x minus 1. Okay, so what you'll notice here is that my common difference is my slope. Okay, my common difference is my slope. Then my y-intercept would be a sub 0. Because a sub 1, my first term is 3. So if I go back 4, if I went backwards, that would take me to -1. Alright, so that was just a little review. So let's move onward to comparing functions. So we're going to start by reviewing it a little bit still. So we're going to write the function, or write the equation of this table. Okay, so I have x and f of x, same thing as x and y, or domain and range. So over to the right, it's asking me for the slope, the y-intercept, and then the linear function, meaning the equation. Okay, so let's start by finding the slope. Sorry, I have to pop the battery out of my pen and put it back in. That usually does it. All right, so we got to figure out how much we're changing. How much are we changing from -31 to -23? If you're not sure, subtract it in your calculator. -31 minus a -23, or I'm sorry, you have to go backwards. -23 minus a -31 to see how much you get. So if I do -23 minus -31, I'm going to see that I'm actually adding 8 each time. Okay, so this is going +8, plus 8 plus 8 plus 8. Okay, so my change in y is 8. So now I need my change in x. So this one, I'm going -8, -6, -4, -2, -0. So you can see I'm counting by 2's, okay? And I am getting larger, okay, because I'm getting less negative. So I'm adding 2 each time. So my change in x is 2, okay? So I was increasing on both of these. And then I'm going to go ahead and simplify 8 divided by 2 equals 4. So then my slope is 4. Next thing I need to do is find my y-intercept. Okay, remember I'm going to go to where x is equal to 0. That's here. And the y with it is my y-intercept of 1. So for my equation, I get y equals 4x plus 1. I'm going to give you a moment to just look over that. All right, so let's go ahead and move on to the next slide. And I'm going to not erase this because we're going to need that again. All right, here's our next one. Write the equation of the graph. So find slope on a graph. Again, I'm going to do rise over run. So on this one, I need to pick some points. So I'm going to start right here because that's my y-intercept. And then here's another point that's nice and in the corner. Here's one, so on. And there's more of them. Okay, so I'm going to draw in my slope triangle. Okay, right off the bat, I should see that I'm rising and I'm running to the left. And if you remember, the left side of the number line is negative. So that tells me this is a negative slope. So I'm going to go ahead and put a negative up here in my answer box. And then I'm going to count my rise over run. So I'm rising 2, 1, 2, and running 1, 2, 3. So my slope is 2 over 3. And specifically, it's negative 2 over 3. All right, y-intercept, that's where we touch the y-axis. That's right here at +2. And then my equation is y equals -2/3 x plus 2. So again, I'm going to give you a moment to look over this in case you have any questions. All right, so now we're going to compare. Okay, so we're going to take the two that we already looked at and we're going to compare them. So we're calling this table f of x and the graph is g of x. Okay, so if we go back to the table, my equation was y equals 4x plus 1. So I'm just going to write it right here, y equals 4. So we've already gone to the work of finding it. And then my graph was y equals -2/3 x plus 2. Okay? So we're going to look at our question here. Select all that apply. So when we're comparing, we need to be looking for things like the slope and the y-intercept specifically. And then there's going to be other pieces to it as well. So select all that apply. The y-intercept of f of x. So my y-intercept for f of x is 1, okay, is less than the y-intercept of g of x, which is 2. So let's kind of plug that into the statement. So the y-intercept of f of x, 1, is less than the y-intercept of g of x, 2. So 1 is less than 2. That's true. So I'm going to check it off. The rate of change of f of x, so that was 4, is greater than the rate of change of g of x, which was -2/3. So again, is that a true statement? 4 is greater than -2/3? Yes, it is. Let's see. Next one. F of -6 is less than g of -6. Okay, so this is where it could get confusing to you, but we are pulling function notation into this. Okay, so function notation on a table can be easy if you have the number there. So if you remember, when we have f of something in parentheses, that's our x value. That's our x value, -6. So I'm going to go up here to my x's on my graph, and here's -6. And so I'll look to see what's with it, and it's -23. if negative 6 was not there, then you could have plugged in negative 6 for the x and y equals 4x plus 1 and solved to get your answer. So negative 23 is less than, and then g of negative 6. So remember, we're finding it on a graph. Again, g of negative 6 means go to where x is negative 6. So I'm going to go on the x-axis here to negative 6, which is here. And I'm going to look down. There's nothing there. I'm going to look up. And I'm right here. And what point is that at? That is at 6. So negative 23 is less than 6. That's true. F of 0 is greater than g of 0. Okay, so f of 0, so that's here, so that's 1, is greater than g of 0. So I go to g of 0 and here, and that's at 2. And that is correct. And notice that this question, f of 0 is greater than g of 0, is the same question as, or is the same statement as y-intercept, okay? Because that's what f of 0 and g of 0 are. They're the y-intercepts, so this is just different ways of saying them. All right, let's keep going. All right, so here's another one that we're going to compare the two, okay? So which is a true comparison of the linear function? Select all that apply. Right off the bat, go ahead and label things you know you're probably going to need, okay? So I know this is my slope, this is my y-intercept, okay? For my table, I need to find my slope. So 5 plus 6 is 11, plus 6 is 17, plus 6 is 23. So 6 over negative 1, plus 1 is 0, plus 1 is 1, plus 1 is 2. So 6 over 1, or just 6, is my slope or rate of change. And B, I'm going to go to where x equals 0, and that is 11. Okay. If I wanted to write the equation on the table, I could. It would be y equals 6x plus 11. Now I'm ready to compare. So which is a true comparison of the linear function? Select all that apply. So the y-intercept of f of x, so that's my equation, and my y-intercept is negative 10. I'm going to write negative 10 is less than the y-intercept of g of x. So g of x is my table, and that's 11. So negative 10 is less than 11. Yes, that is true. The rate of change of f of x, that's negative 8, is greater than the rate of change of g of x. And we found that already, that's 6. Negative 8 is greater than 6. Nope, that is false. F of 1 is less than g of 1. All right, so this time to find f of 1, I've got to plug in, okay? So I'm going to say f of 1, so negative 8 times 1 minus 10, right? So negative 8 times 1 is negative 8. Minus 10. And then same signs, we're going to add 8 plus 10 is 18. And we're going to keep that sign. There we go, negative 18. So I'm going to write that down here. Negative 18 is less than. And then g of 1, so here's my 1, and that's 17. So negative 18 is less than 17. Yes, that's true. Now I have f of negative 1. F of negative 1. So again, I'm going to go up here. I'm going to plug in. Play negative 8 times negative 1 minus 10. Negative 8 times negative 1 is 8 minus 10. Different sign, so I'm going to subtract. 10 minus 8 is 2. Keep the sign of the bigger number. 10 is bigger and it's negative, so negative 2. So negative 2 is greater than g of negative 1. So that's here, which is 5. Negative 2 is greater than 5. Not true. And then last one, none of the statements are true. Also not true. All right. From here, we're going to move on to reviewing solving linear equations. Comparing functions will come back. That's something you should have done last year in 8th grade, but I did want to just review it for you. And again, this is also review. So we're going to talk today about solving multi-step equations. When I used to teach 8th grade at Laverne Middle School, I used to teach my students DCMS, distribute, combine like terms, move the variable, and solve your equation. So those are the steps we're going to follow today as we review. So what I would like you to do is either on a dry erase board or in your notebook, work these out. If you feel like you remember how to do this and you don't need the review, then just go ahead and pause your screen, work the problem out, and then watch me go over it to see how you're doing. If you need step-by-step instructions, work the problem along with me. So we're going to start by drawing a line down the middle of our equal sign, and that's to help keep our work organized. So step 1 is distribute. Okay, so I'm going to start on the left side. I don't have anything to distribute, so that means I just bring down what I have, including my equal sign. And on the right side, I can distribute 3 times x and 3 times 6. So 3 times x is 3x, and 3 times 6 is positive 18. Be very careful, because the biggest mistake I see is people write 3x plus 6 because they don't distribute against the 6. Anytime you have something outside parentheses, it distributes against everything. All right, next step, combine like terms. When we combine like terms, it has to be on the same side of the equal sign. So on the left, 6x and 3 are not alike. On the right, 3x and 18 are not alike. So we can skip that step because we don't have it. Next step is move the variable. Okay, we have x's on both sides. We need them on one side. It doesn't matter which one you move. Okay, you can move either one and you're going to get the same answer. However, if you move the smaller number, then it's easier to keep your answer positive. Now, of course, there are some cases where you can't keep it positive. It's going to end up negative either way. But if you can keep it positive for a little while, this helps. So I'm going to move 3x because it's smaller. Because if I subtracted a larger number, that would put me negative right away. So 6x minus 3x is 3x. I still have a positive 3, so it comes down. 3x minus 3x makes 0. Notice I don't say cancels out. Cancels out is not a thing in math. Okay, you guys don't know what it means when teachers tell you cancel out. The reason we cross this out is because 3x minus 3x is 0, and we don't need to write 0. And then we just bring down 18. Okay. Now we're ready to solve, because now we just have a two-step equation. So remember, in order to solve an equation, we need to get x by itself. Right now, x still has a positive 3 beside it, so we've got to move that first by doing the opposite. Bring down what's left. 3x equals 18 minus 3 is 15. Feel free to use a calculator to help double check your integers on these. And then divide on both sides. So get x is equal to a positive 5. Okay, here's our next one, a little bit larger equation, more steps. Again, if you want to just try it on your own, go ahead and pause your screen and try it on your own. Then unpause to see how you did. If you want to work it along with me, go ahead and copy it down to work it along with me. So again, draw the line down the center. We'll start with step 1, distribute. The very first thing I come to is a 4. That 4 is not attached to the parentheses, so it just comes down. And then I have a 2 that I'm going to distribute. So I have 2 times x is positive 2x. 2 times negative 6, a positive times a negative makes a negative 12. Equals. I'm going to distribute on this side now. 3 times x is 3x. 3 times 4 is positive 12. And then plus x just comes down. Next step is to combine like terms. Okay, so I'm going to get my highlighter out so I can highlight like terms. So on this side I have a 4 and a negative 12. Okay, 4 and a negative 12. On the right side, I have a 3x and a positive x. Let me switch back to pen. All right, so I'm going to combine. I'm just going to bring my 2x down first, because I like to keep my x first. And then I'm going to combine. So 4 minus 12. Okay, just read it just like the signs say. 4 minus 12. Again, if you need to check that in your calculator, you can. It's going to give you a negative 8. Equals. Then again, I like to keep my x's first. So 3x plus x, meaning 3x plus 1x is 4x. And bring down your positive 12. Okay. Now we're to move the variable. So I can move either way, but again, I prefer to move my smaller number. So I'm going to move 2x by subtracting because it's positive, so I have to do the opposite. So 2x minus 2x makes 0. Negative 8 comes down. 4x minus 2x is 2x. And then plus 12 comes down. And now I'm ready to solve. So let's get x by itself. I'm going to move this 12 by doing the opposite. 12 and negative 12 make 0. Now I have 2x equals a negative 8 and a negative 12. Same sign, so I'm going to add, keep the sign. Divide by 2, and x equals a negative 10. All right, here is our next one. So same thing, work along with me or pause and then check your work. Let's start with step 1, distribute. 4 times x is 4x. 4 times 3 is positive 12. Equals. I have nothing to distribute here, so I'm just going to bring everything down. It's better if you just do a step each line instead of trying to combine steps in one. All right, next up, combine like terms. So 4x and 12 are not alike. I do have a 2x and a positive 2x, and then I actually have 2 like terms on this side, so I'm going to change colors. Try orange, and a positive 5 and a positive 7. Alright, so I have 4x plus 12 on this side, and then 2x plus 2x is 4x. 5 plus 7 is positive 12. When you get to this point, you should hopefully notice that you have the same thing on both sides. 4x plus 12 and 4x plus 12. Anytime you have the exact same equation on both sides, this is a special case, which we call infinite solutions. Okay? Or you can say all real numbers. Here's why. If we were to continue, then we would move a variable. So if I, lost my pen again. All right. If I subtract 4x on both sides, that makes 0, that makes 0, and all I have left is 12 equals 12. And I would ask myself, does 12 equal 12? Yes. Does 12 always equal 12? Yes. So its infinite solutions are all real numbers, which means you could plug in any number to both equations and get the same answer. If I plug in 1, 4 times 1 is 4, plus 12 is 16. 4 times 1 is 4, plus 12 is 16. Okay? So as soon as you get to that point where it's exactly the same on both sides, it has to be the same signs, exactly the same, it's infinite solutions. All right, next up. So again, step 1, distribute. 3 times x. 3 times 5 is positive 15. 3 times x is 3x. 3 times 4 is positive 12. All right, this time we have the same slope on both sides, 3x and 3x, but 15 and 12 are not the same. So let's go ahead and go another step to see what happens. So nothing to combine, so I'm going to move the variable. It's the same variable on both sides, so either way I go, I'd be subtracting 3x. So 3x and negative 3x make 0, and I have 15 left, equals 3x and 3x make 0, and I have 12 left. And I would ask myself, does 15 equal 12? No, it doesn't. So we say 15 does not equal 12. This problem has no solution, which is your second special case that you would have learned about last year. All right, next up is we're going to add in fractions. So we have one extra step now. Pause with me for just a second while I grab a drink. Sorry about that. My throat gets dry making these videos. Okay. So now we have DDCMS. Distribute denominators, combine like terms, move the variable, solve. So I'm going to draw my line. Okay, so make sure you're doing this along with me. This may be something new for everybody. I would be writing this in your notebook, title it Solving Equations with Fractions. Write your steps down that I have here on the left. Remember, you're in control of this video, so you can press pause at any time to get caught up. Right, so the first step is still distribute. So I don't have anything to distribute on this side. So I'm going to bring down 1/3 x plus 3 equals. Then I'm going to distribute over here. 3 times x is 3x. 3 times 6 is positive 18. So now I have 1/3 x plus 3 equals 3x plus 18. Okay, in order to get rid of a denominator, you need to multiply by it. Okay, you need to multiply by it. So what I'm going to do is I'm going to put this side in parentheses, and since my denominator is 3, that's what I'm going to multiply by. What you do to one side of an equation, you have to do the other. So I also have to multiply this one by 3. So in essence, I'm distributing again. Right? Now, when you multiply a number by its denominator, it basically becomes 1. The denominator becomes 1. I'm going to show you what happens right here so that you can understand it better. I think that the way I said it doesn't make sense. So let's say I have 3 times 1 over 3, which is what I have up there. 3 times 1 over 3 means 3 over 1 times 1 over 3. So 3 over 1 is 3 times 1 over 3 is 3, which equals 1. Okay, so basically when you do this, your denominator is going to become 1. Now your numerator should stay, you know, whatever it is. So if it was 3 times 2/3, okay, then I would get 3 times 2 is 6, 1 times 3 is 3, 6 over 3 is 2, which is what my original numerator was. Okay, best thing you could do is use your calculator to double check it. Because again, I hate to use that term, cancels out. But basically, that's what happens. Okay? So if it helps you to think about it that way, you can. So you could say 3 times 1/3 means these cancel out. And all I have left is the numerator, which is 1x. But I still have to distribute 3 again. So 3 times 3 is positive 9 equals. Then I have to do this side. Okay? So 3 times 3x is 9x. 3 times 18, so you may want to use your calculator. It's going to be a positive 54. So it's going to make your numbers larger, but it's more manageable to work with than the fraction. No like terms to combine, so I'm going to move the variable. So this is smaller, so I'm going to subtract 1x on both sides. And I get 9 equals, 9x minus 1x is 8x plus 54. Still need to get my my x by itself. So I'm going to subtract 54 on both sides. So I have 9 minus 54. And again, double checking my calculator. All right. So 9 minus 54. It's going to give me a negative 45 equals 8x. And then I'm just going to divide. I get x equals negative 45 over 8. Now, I know that this is probably going to bother some of you that we leave it as a fraction, because I know in middle school you didn't do many equations like this, but in high school we just leave it. Because if we wanted to plug in that negative 45 over 8, we can easily do that. Okay, so let me go over here for a second. Because I think, if I remember correctly, I've got the Desmos calculator somewhere. where you guys could see it. Desmos. There it is. Sorry guys, just waiting for it to load up here. Okay, so with this, I'm going to switch it to calculator right here, and I can plug in to see that this is correct. So negative 45 over 8. So I'm going to type in 1/3. So 1 divided by 3. And then it's times x. So my x is negative 45 over 8. So negative 45 over 8. And then it's plus 3. So plus 3 gives me 1.125. All right, so now I'm going to go down 1. So I've got 3. And then times, and then x, which again was negative 45 over 8. And it's plus 6. So I gotta get all that in parentheses together. And if you notice, it's the same answer, 1.125 and 1.125. So I can see that I do have the correct answer here. Okay, you can download this app on your computer. You can download it on your phone. The calculators we have at school, we can plug in the fractions on. But I just want you to realize that you are able to double check these fraction answers. Okay. Let's go ahead and try to get through just a couple more of these, at least one more. All right, so here's our next one. This one's multiple choice, so we're going to work it out first, though. All right, so again, let's follow our steps. So distribute is first, so I can't do anything to this side, so I just have 1/4 x plus 5 equals. And then distribute 4x minus 4. Now denominators, my denominator is 4, so I got to multiply by 4 on both sides. Okay, so remember, all I have left here is 1x, but I still have to multiply 4 times 5, which is positive 20. 4 times 4x is 16x, and 4 times negative 4 is negative 16. Now combine like terms, don't have any, so I'm going to move a variable. 1x is smaller. Take 20 equals 16x minus 1x is 15x minus 16. Still need x by itself, so I'm going to add 16 on both sides. I get 15x equals 36 and divide by 15. So I get x equals 36 over 15. Now we could simplify 36 over 15 because both are divisible by 3. So I could say 12 over 5 because 3 times 12 is 36, 5 times 3 is 15. But you're going to notice that either way your answer is in decimal form here. So in this case, it does want you to convert it to a decimal. So then all we need to do is take that 36 divided by 5. Whoops. And that gives me 7.2. Oh, I'm sorry. 36 divided by 15. I thought something was off. 15. That gives me 2.4. Therefore, my answer on this one would be answer choice A. we got just one more we're going to do today, and then we'll be finished for the day. So again, we're going to go through our steps. Distribute first. 4 times 2x is 8x. 4 times negative 18 is going to be negative 72. 4 times 10 is 4. Yep, 72. All right, next up, denominators. My denominator is 2. If you like it better, you can put the 2 in front of the parentheses on this side. So remember this one, all we have left is 1x, but then we still have to do 2 times 3 here. And on this side, 2 times 8x is 16x. 2 times negative 72 is going to be negative 144. No like terms to combine, so I'm going to move the variable. Again, I always like to move the smaller of the two, so I'm moving 1x. So I get 6 equals 16x minus 1x is 15x minus 144. Add 144 on both sides. Get 15x equals 150. Divide by 15, and this time it does come out to a whole number. X equals 10. So we're going to stop here for today. Make sure that you do take your mini quiz. It does need to be completed today. I won't put a stipulation on you of 3:30 since this one is not in Desmos. But I do need to have it by the end of the day or it's going to count as a 0. And when you do submit it, it would be your retake. So then you'd have 0 plus whatever you get, which means you're basically only getting half credit for it. So please make sure you're doing your tests when you're supposed to be doing them. Second, please make sure you are submitting your Microsoft forms when you're supposed to be submitting them. They are time-stamped. So if when we receive them, you did not submit it by midnight on the day it was due, it does not count. And lastly, this is Progress Reports week. So progress reports come out on Thursday. We'll be sending emails to your parents. So just make sure you're keeping up with your work and have a great day.